Hi guys, I'm back. Sorry my phone kept cutting out. It stopped again, but I think I've taken care of the technical difficulty. So this is like part 3 of 3 for muscles. And exactly where I left off was I was just going to write on the board the actions of teres major, which is to adduct, extend, medially rotate arm. Adduct, extend, medially rotate arm. This is adduction. Bring your arm back. This is extension. Once again, this is medial rotation. All right, moving on. 2 questions for you. Give you a second to think about that. All right, name the actions for latissimus dorsi and teres major. It's the same for both. They both, again, adduct, extend, medially rotate arm. Right here. Name a muscle that can both flex and extend the arm. Well, the anterior part of deltoid can flex it. The posterior part of deltoid can extend it. Demonstrate actions of Pectoralis major and Coracobrachialis. Pectoralis major, it could adduct the arm, it can flex the arm, it can medially rotate arm. For Coracobrachialis, it can only adduct arm and flex arm. All right, moving on. The biceps brachii and brachialis, we're moving on to a category of muscles that can now move the elbow. So we're kind of getting done with this joint here, shoulder, getting down to elbow. All right, so here's some pictures. This one, here we see pectoralis major. We got the delts. We have biceps brachii, the main muscle of the arm there. Here it is more dissected. We can just see the biceps brachii. And in this dissection, when you remove delts, pecs, you can kind of see the long tendons of the biceps brachii go up, and they're actually going to originate from points on the scapula. Okay? And it's going to insert down here past the elbow. If you remove the biceps brachii, there it is, more superficial. Underneath, we see another muscle I want you to know, the brachialis muscle. And I put the bracket here showing the length of the muscle because that's a rule I want you to know. Generally, in anatomy, longer muscles are more superficial. There are exceptions. Okay, rule. Longer muscles are more superficial. For example, let's say you got your classic hinge joint there, and you have muscles that cross that joint. Let's say you have this muscle crosses the joint just like that. Let's say that's the deeper muscle. Well, if the muscle is going to be on top of it, more superficial, I mean, wouldn't it have to be longer in length? Pretty much, longer muscles, they're more superficial. They have to be longer to be more superficial across the joint. Alright, there's a blank figure you can study. Let's start with the biceps brachii. Two origins. So I have this is shoulder joint there, and I've really blown it up so I can kind of point out these two locations for the two origins of biceps brachii. The O's, Coracoid Process, and supraglenoid tubercle, that little bump on the superior aspect of the glenoid. Remember, both of these are on which bone? Scapula. Moving on, I just want you to see those two origins on an actual picture here. So, the coracoid process, something you should know, this is the origin for the short head. Here's the short head. You should be able to identify short head. Goes up there, coracoid process. So this one, I'll just put short for the short head. Long head. That's got that long tendon, runs in the bicipital groove, right? Or intertubercular groove. It's going to go all the way up there. It disappears there, but it's going to end up at the supraglenoid tubercle. So this is for the long head. And I'll remind you, the tendon runs in the bicipital groove for the long head. Tendon runs in bicipital groove. Let's look at the two insertions shown here. So the two heads, long and short, they come together and they form one muscle. So this is kind of like the two heads come together, you got one muscle. And then here's the elbow joint. You're crossing the elbow joint. One insertion is not a bone. It's a connective tissue called the bicipital aponeurosis. And the other is on the radius bone. There's the biceps tendon, and it's inserting on radial tuberosity. So let me write those down for you. Still on the biceps brachii. So the insertions, one is radial tuberosity. Obviously, that's on the radius bone. And the other, again, is not skeleton, but connective tissue, called the bicipital aponeurosis. All right. So another rule in this area of the forearm, if a muscle has an attachment to the radius bone, it can affect pronation supination. Because remember, pronation supination, it's the radius bone that radiates and the ulna stays still. So muscles that attach to the radius can affect pronation supination. So I'll write that as a general rule. Muscles that have an attachment to the radius can affect pronation supination. one or the other, or sometimes both. Turns out the biceps brachii is a very powerful supinator. And we'll get to that on the next slide. In terms of this insertion here, the Bicep Aponeurosis, like if you kind of clench your fist and kind of feel on this part of the inside, you kind of feel a tension there, and that's you're tensing this tissue, kind of making it feel hard right there. All right, so that's the other insertion. Let's go over the actions of this muscle. In learning the actions of biceps brachii, well, it's a three-joint muscle, so it can do three things, and they're listed here. Think of the shoulder joint right here. It can flex arm because that short head, it has an attachment on the scapula, so it can help flex arm. Moving the shoulder joint. This is, I'm sorry. Ooh. Well, actually, you know, both attachments are on the scapula. So what I'm going to put is, it can flex arm because it crosses the shoulder joint. People usually forget that about the biceps brachii. It's usually the one where you go, raw, you flex the elbow. It also flexes the shoulder. So flex arm, remember it crosses shoulder joint. Both of those origins, supraglenoid-tubercle, coracoid process, those are on the scapula. So you're crossing the shoulder joint. And everyone pretty much knows it flexes elbows. When you work out in the gym, flex those dumbbells, flex forearm. So the elbow is a hinge joint. That's another joint, shoulder, elbow. But also you got that, those radial ulnar joints that we talked about, because it's a powerful supinator. So it can do this, like when you turn a doorknob, you can feel your biceps contract. So it's a powerful supinator. It supinates. Doesn't pronate, it supinates. Okay. That's why you ever do like pull-ups versus chin-ups. A pull-up is you grab the bar this way and pull up. A chin-up is you're supinated and then you pull up. Usually the chin-ups are easier because when you're pronated, you turn this muscle a little bit. You put a little kink in it, and that makes the biceps weaker. That's why pull-ups are harder. So if you want to get your biceps a better workout and get more power, do chin-ups. All right, let's move on. Here's the brachialis. You know, as I erase the notes for the biceps brachii, it's interesting that the biceps brachii, it's the, you know, the main muscle of the arm, but it actually has no attachments on the arm. It attaches here in the scapula and down here past the elbow. But you know, it's your guns, right? It's the gun show. Let's move on to brachialis. There it is right there. Next slide, I got it highlighted with the attachments. We describe the brachialis as a pure elbow flexor. Pure meaning that it doesn't do anything else. Flex elbow. That's the action of brachialis. A pure elbow or forearm flexor. Again, that started from the anatomical position, just flex elbow. All right, I got the O's in the eye here. The origin, I describe that as basically humerus, the distal half, all on the front anterior surface. Humerus, distal half, anterior aspect. The insertion, it goes past the elbow, right there. It inserts on the ulna. So let's call that, well, it's the coracoid process, ulnar tuberosity. I don't think ulnar tuberosity, I can't remember if that's on your study list or not, but know that for the insertion for the brachialis. Coracoid process. It's that little, see if I can point there, it's that little tip, coracoid process, but it extends down a little bit, and you'll see the ulnar tuberosity there. You can look that up in one of your books if you want. But this is all, that's all ulna, okay? All right, so this muscle cannot affect pronation or supination. It attaches to ulna, not radius. All right, let's move on. Triceps brachii, let's go to the back of the arm. There's other muscles back there. This is the only one I got. I want you to know. Triceps, named for how many heads we got. I mean, we talked about the biceps brachii, named because it has two heads, and it's of the arm. Brachialis also means arm. So now we're on the triceps brachii, which is a three-headed muscle of the arm on the posterior aspect shown here. There's three heads. I only teach two of them. The long head, and then this lateral head. There's a medial head underneath there. It's really deep. We never see it. I usually don't teach it. Don't worry about it. You have to know this long head there and this lateral head there. Okay? So no long and lateral head. Let's go over the O's and I's for that. For the long head, it originates infraclinoid tubercle. They all insert onto the olecranon. The origin for O. So let's remember, this is a structure on scapula. So again, this is only the long head. So infraclinoid tubercle, it has an origin on the scapula. It's going to insert all the way down past the elbow on olecranon. So let's think for a second, how many joints are you crossing? 2. If you attach to the scapula, you can move shoulder joint. If you go past the elbow, here or on the ulna, you can extend at the elbow too. So that's why this can extend arm and forearm. Extend arm and forearm. So again, you extend the arm, that's movement at the shoulder joint. You extend forearm, that's movement at the elbow. So extend arm, that's shoulder, forearm, elbow. the other head, the lateral head, the lateral head, it can only extend at the elbow. Extend elbow. Or again, different way of saying the same thing, extend forearm. Because it originates proximal humerus, posterior aspect. If it starts on the humerus, it can't move that, right? If you originate here, can't move that joint. Only extend elbow. So when you do the tricep kickbacks at the gym, that works out. If you want to work out the long head more, you can just do a little extension, with your tricep kickback to emphasize working out the long head. But they all extend the forearm. Okay. There's a blank picture you can study. I wanted to sneak in a couple of muscles of the thorax, muscles of the rib cage. So just know external, internal intercostals shown here. Here's a complete picture of what we're looking at. Here's the whole rib cage. And we're just talking about the muscles that fill the intercostal spaces. The external intercostals, because they're external, they're more superficial, they kind of stop here at the edge of the bony rib. But the internal intercostals go all the way to the sternum, but they both go all the way to the backside right there. Okay. So just know, closer up view, external intercostals, internal intercostals. So it's all the ones between the ribs, all these intercostal spaces. So generally, intercostal muscles I'll say occupy intercostal spaces. The external intercostals, I'll just give you the insertion. They insert on the rib below it. So if I'm talking about this muscle, they insert on the rib below it. This muscle here, it inserts on the rib below. External intercostals insert on the rib below. So when it contracts, it basically elevates ribs. Okay? It's like when you take a breath in, your rib cage expands a little bit from side to side because each rib is being elevated. So the action is elevates ribs during inspiration. Like when you're inspired, something goes inside you and you're inspired, and taking a breath in, inspiration, the air goes in. So then the internal intercostals help to depress ribs during expiration, a breath out. Just going to change the key words here. The internal intercostals insert on the rib above it. Change that word too. To depress ribs during expiration. Pretty much only during like heavy exercise when you're really huffing and puffing. So when you take your breath out, your rib cage expands. Usually breathing out, expiration is a passive process. You usually don't have to recruit muscles to do that, but during heavy breathing as an exercise, you recruit muscles like the internal intercostals. So I say it inserts on the rib above it. If you insert on the rib above, you can pull down, hence depressing ribs. All right. Oops. Move on. 2 questions for you. Give me a second to look at that. Let's go over these. Why is biceps brachii a 3-joint muscle? It moves 3 joints. It can flex shoulder, flex arm, that's 1. It can flex elbow, so it can flex the forearm, that's 2. It's a powerful supinator, so that's that forearm joint, the radial ulnar joint. Okay, so that's 3. Number 2, name the actions of the long head of the triceps brachii. That can both extend arm and it can extend forearm, extend arm. Once again, the long head can extend forearm, extend arm. But the other head, I want you to know, the lateral head, can only extend forearm. 2 insertions for biceps brachii. That's the radial tuberosity and the bicipital aponeurosis. Name insertions, each for triceps brachii and brachialis. The triceps inserts onto olecranon, the brachialis inserts onto the corocoid process and ulnar tuberosities. And I know all your tests and quizzes are going to be open book, open note. You can just look this stuff up. But it's better if you just know it, if you want to take my advice. You'll be a little frustrated, you'll be just thumbing through everything. Why is it that the brachialis cannot affect pronation or supination? It's because of its insertion. It inserts on the ulna. The ulna stays stationary during pronation supination. The rule I gave you is a muscle must attach to the radius to affect pronation supination. Moving on. Forearm. The forearm has basically 2 compartments, the front and the back. So in anatomy we say anterior compartment, posterior compartment. And there's some general rules I should go over before we get into it. I'm going to start with the anterior compartment. Forearm in general, think of it as 2 compartments. Anterior, posterior. The innervation is different. Muscles of the anterior compartment, they're usually innervated by mostly median ulnar nerves. Posterior compartment, the innervation is the radial nerve. The anterior compartment, basically like right here when we did the EMG of that compartment from there to there, and you clenched, we call these the flexor compartment. So the anterior compartment are flexors. The posterior compartment, when you extend your fingers, that's this compartment. These are extensors. This picture here, these are all flexors. If you go like this, and put your four fingers across there, on this side, that's medial, that's lateral. So all the flexors originate from the medial epicondyle, all the extensors originate from the lateral epicondyle. It's another general rule that's mostly true. So the O's for the anterior, they all have this common flexor tendon, common extensor tendon. Medial epicondyle. Posterior compartment originate lateral epicondyle. So what we got here, so you don't have to turn your sideways, the fingers approximate what the muscles look like when you dissect. Pronator teres, flexor carpi, radialis, palmaris longus, flexor Ulnaris. There are actually 3 layers of muscle. I only have time to do the top layer there, so appreciate that there are many more muscles that I'm teaching. Let's look at these 4. Pronator teres, flexor carpi radialis, palmaris longus, flexor carpi ulnaris. Here's some pictures to learn from. So we got our skeleton outline, we got our humerus, radius, ulna, and all our hand bones there. And here are the muscles I talked about, those 4. They just kind of lay out like that, or like that on the other arm. So they're hard to see. They're slender muscles, difficult to visualize on a picture. So what I did was I kind of highlighted them green. I put the O's and the I's right next to it for clarity. It's the pronator teres. Muscle is named for what it does and because it's round. That doesn't look round, but I think in cross-section it looks a little more round. Teres means round. I don't know exactly why they call it pronator teres. We'll just go with it. I'll start with the obvious. If the muscle is named for what it does, you know what it does. It pronates. And you know, for naming that movement, pronation, supination, you don't even have to say of what. Pretty much it's understood, it's the forearm. So just say pronates, it's fine. But because it crosses the elbow joint, it can help flex. It originates, again, they all originate medial epicondyle. It's going to insert kind of mid-shaft lateral aspect of humerus, just like I have there, okay? And I'll take my time, I'll list it here. radius, midshaft, lateral aspect. It's important you get into the lateral aspect. So when it contracts, it's gonna spin the bone this way. It's gonna like pull it this way for pronation. It's gonna pull it this way for pronation. Next muscle, right next to it. Flexor Carpi Radialis. A muscle name for what it does and where you can find it. I'm going to leave the O. They all have the same one. Change everything else. I'm going to stop right there. You know what it does. What's that mean? Wrist. Flex wrist. In the anatomical position, that's flex wrist. Okay, just like this. Flex wrist. Radialis. That's the full name. So, Flexor Carpi Radialis. That's the full name of the bone. It inserts on the radial side. Okay, just remember, thumb is rad towards that side, radialis. So, originates medial epicondyle and inserts base of second metacarpal. Of course, we're talking about the palmar aspect here because we're in the anterior compartment. So remember, that's number one, that's digit 2. So the base of the second metacarpal is right around there where the blue dot is. Base of second metacarpal, palmar aspect. I'll say palm. It's on this side, not this side, not this side, this side. So basically, the main action is flex wrist. These aren't the most powerful elbow flexors, but they do help flex forearm, so I will list both. It does cross the elbow joint. It does cross the wrist joint, crossing 2 joints, elbow, wrist. And forearm. Moving on. Palmaris Longus. This one is absent in something like 11 or 14% of people, depending on which book you read. You can see the tendon of it. Let's see if I can show you. See that tendon popping out there? Right there. Tendon of Palmaris Longus. So, I see the tendon, I know I got it. If you don't worry about it. This one, it can flex wrist, flex forearm, but because it inserts on this palmar aponeurosis, it can also tense skin of palm. So let's write that all out. I already have flex wrist up there, so it can flex wrist. Because it crosses the elbow joint, it can flex forearm. And because it inserts on the palmar aponeurosis, which is a connective tissue deep to the skin. It's not skeleton, it's connective tissue. CT, just like the bicipital aponeurosis. You can kind of tense like skin of palm. Like if you kind of like just kind of flex like that and feel the skin of your palm, it's all like tense. So I'll list that action associated with this. Tense skin of palm. And the muscle contracts, it pulls that tight. Moving on, next muscle. Right next to it, you've got the Flexor Carpi Ulnaris. I'm going to leave these things because they're the same for Flexor Carpi Ulnaris. Again, it can flex forearm, it can flex wrist, and it's on the ulnar side, okay, hence ulnaris. So we got radial side rad, and the other side on the pinky side, that's the ulnar side. It inserts base of fifth metacarpal. Let's move on to the posterior compartment. This one's a little more tricky. A lot of muscles back there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 muscles. Brachioradialis, Extensor Carpi Radialis Longus, Extensor Carpi Radialis Brevis, Abductor Pollicis Longus, Extensor Pollicis Brevis. You can see the tendon of Extensor Pollicis Longus. I put these in red. Notice it goes longus, brevis, longus, brevis, longus. It alternates between longus and brevis. And you got 3 on this side. Extensor Carpi Ulnaris, Extensor Digiti Minimi, Extensor Digitorum. Just categorize them this way. 3, 3, and 3. 3 movers of the thumb, 3 extensors of digits, 3 radialis muscles. So 9 muscles in posterior forearm. Three moves of the thumb. Abductor Pollicis Longus. Extensor Pollicis Brevis. Extensor Pollicis Longus. Okay, I'm gonna go fast. Remember, you can always hit the pause button. Extend digits. And wrist. Extensor digitorum. Extensor digiti minimi. And extensor carpi ulnaris. That's why I added wrist, because this one extends the wrist. The others extend the digits, but think of those three as a group of three. And then 3 radialis muscles. This is the thumb side. So remember, radial side. Brachioradialis, Extensor Carpi Radialis Longus, Extensor Carpi Radialis Brevis. Four words, know the correct order. Yeah. Let's go through them. Here's a picture of our attachment figures. There you see the 3 muscles. All the other ones are gone, just those 3. You can barely see brachioradialis there, but you see these 2 other extensor carpi ones. Okay, so I chose a different view. This is a posterior view. This is a lateral view, so you can see the 3 muscles better from a lateral view. But here's the posterior view again of the attachments. So let's do the brachioradialis first. You know, if you, I haven't mentioned this yet, but if you compare the muscles I'm presenting online, compare the slides I'm presenting online to the slides that were previously posted for muscle. I have more slides here. I mean, because we don't have a lab time where I can help you with the models, I've had to expand out and add more pictures so it's more clear since we don't have a lab time together. So these are better than the slides previously posted. I feel it's necessary because we don't have our usual lab time. I'll do it. Okay, brachioradialis, a muscle named for its attachments. And students always mix this one up. They call it radiobrachialis. I've heard it called a bunch of different things. Brachioradialis. Named for its attachments, the origin to the insertion. There's the O. There's the I. This is an exception muscle because it's basically a flexor of the elbow, but it's in the extensor compartment by innervation. Okay, but okay, let's go with it. What are we looking at here? It originates distal humerus, pretty much way up here, above the lateral epicondyle. So let's just call that distal humerus. It inserts styloid process of the radius right there. It does not cross the wrist joint. So what joint does it cross? Pretty much the elbow. So its actions, because remember our rule, it attaches to the radius so it can affect pronation, supination. What we say it does, it semi-pronates. So full pronation is you fully turn your forearm like that. fully. Mid-pronation is just kind of turn it like that, so you give the thumbs up sign, and then you flex like that. So we call this the root beer drinking muscle. And you grab a mug, you semi-pronate, grab the mug, flex, your root beer drinking muscle. Semi-pronation, flex, elbow, in that order, as in drinking root beer, or beer if you're old enough. That's the funny anatomy thing, it's your beer drinking muscle. Okay. The Brachioradialis. It's an exception muscle. It's a flexor. It doesn't cross the wrist, okay, but it's still part of this posterior compartment. Moving on. Extensor, Carpi, Radialis Longus. Going in order. Extensor, Carpi, Radialis Longus. The muscle is named for what it does. Extend wrist. Radialis tells you what side you can find it on. Is it this side or is it that side? It's on the radial side. Okay. Longus because there's a brevis. So it originates lateral epicondyle. So let's remember, that's the humerus. Inserts base of second metacarpal. You could see that there. You can see it again. There's first metacarpal. There's second metacarpal. So there's the tendon right there. So its action can extend wrist. That's the name. I'll write it up here. Moving on. Muscle right next to it, extensor, Carpi, Radialis, Brevis. I'm just going to change a couple things here. Change that to Brevis. It extends wrist, originates pretty much still, lateral epicondyle. It inserts base of third metacarpal. That's pretty much it. Those two muscles are right next to each other. Just don't confuse them. Remember, the longest one is more superficial. The brevis is deep to it. So there's the base of the second metacarpal, base of the third metacarpal for this muscle. And we're moving on. We're going to talk about extensors of the wrist and digits now, these next group of three. We're going to start with extensor digitorum. Well, named for what it does. It extends digits, these ones, 2, 3, 4, 5. So extends digits 2 to 5. I'll start with that. So 2, 3, 4, IV, 5. 2, 3, 4, 5. Always use the Roman numerals in anatomy, they really like that. So it originates, same thing, way up here, lateral epicondyle. It inserts. It's going to way down here, the muscle does, then the tendons kind of fan out, and they go to digits 2, 3, 4, 5, all the way to the distal phalanges of those digits. Next muscle, extensor digiti minimi. Again, it tells you what it does. Extends the small digit, digit 5. I believe the correct pronunciation is extensor digiti minimi, but I like to say minimi because that character Mini-Me in the Austin Powers movies, he always went like this, you extend the digit. Thought that's kind of funny. Anyways, it's a very slender muscle. It's difficult to see. I have it highlighted in green there. It's going all the way. Inserts into the distal phalanx of digit 5. I'll just give you the I. The O has been the same. And then the muscle right next to it, the extensor Carpi Ulnaris. The muscle is named for what it does. It extends the wrist. You can find the muscle on this side. That's the ulnar side, right there. Okay. So again, ulnar side, radial side. Again, the O is the same. Lateral epicondyle. This one inserts base of 5th metacarpal right around there, right around there. I should have extended the green line down to there. I stopped it short there, so I'll fix this before I post it. Inserts base of 5th metacarpal, extend wrist. It definitely crosses the wrist joint. Let's move on. 3 muscles that move the thumb. Abductor Pollicis Longus, Extensor Pollicis Brevis, Extensor Pollicis Longus. They're very deep there, but you can see they're all going to the thumb. We're not going to talk about this one. This is the extensor indices. Basically, you go like this. Anyways, the 3 muscles of the thumb. Abductor Pollicis Longus first. Okay? So it's going to go boom, Abductor Pollicis Longus, Extensor Pollicis Brevis, Extensor Pollicis Longus. So starting with this one. have to kind of describe movements of the thumb. It's different for the thumb than other fingers. Because other fingers, you got your these 4 fingers, they're all in the same plane. But notice when you hold your thumbs together, the thumbnail is kind of at a 90-degree angle to the other ones. So for abduction, adduction of the thumb, it's kind of movement out and back. It's kind of like if I hold my hand to the side, I'm make an L like this and bring it back. That's abduction, adduction, kind of like that. Kind of like doing sock puppets. Abduction, adduction. Okay, so abduction, adduction from the anatomical position. I don't know if you can see my hands there. What I want to say is this movement, when you go out and back, that is movement in this plane, front to back. This is the sagittal plane when you move this way. Sagittal plane, sagittal plane. So abduction, adduction of the thumb is movement in the sagittal plane. Okay, let me write that down. Abduction, adduction of the thumbs, movement in the sagittal plane. That's different. Normally, flexion, extension, like moving your arms back and forth, that's movement in the sagittal plane, but not for the thumbs. It's abduction, adduction is their movement in the sagittal plane. It's that thing where the nail is juxtaposed at a 90-degree angle to the other fingers. That's why in the anatomical position, different. So it's the same thing for flexion, extension. Flexion, extension is when you move your thumbs back and forth like this, like windshield wipers. Okay, not out and back. That's abduction, adduction. This is flexion, that's extension. That's flexion, extension of the thumbs, movement in the frontal or coronal plane. Flexion, extension of thumbs is movement in the frontal plane. All right, so now that's out of the way. Abductor Pollicis Longus abducts the thumb. That's like if you look straight to the side, moving it out like that, then moving it back. Okay, if I point it straight at you, moving it out towards you, that's abduction. So I'll start with that. The muscle is named for what it does. But there's a longus there because there's a brevis as well. Remember, thumb is pollicis. I'm just going to say that these originate, there's a membrane in between ulna and radius. It's what's called the interosseous membrane, which means a membrane between bones, and this is what it is. The muscle originates on that membrane. So its tendon goes down and it's going to insert on the base of the first metacarpal. So that's right around there. I'm going to move on. Extensor Pollicis Brevis. So once again, Abductor Pollicis Longus in green. Extensor Pollicis Brevis. It's going to extend down a little more and insert base of the proximal phalanx of the thumb. Going to change out what's different. The muscle is now Extensor Pollicis Brevis. It extends the thumb. Okay, so like make the number 4. Your thumb is flexed. You just move it straight back. That's flexion. Flexion, extension of the thumb. There are flexors of the thumb. Well, we're not doing them, but you can look them up if you want. Extends the thumb, originates interosseous membrane. It inserts proximal base of proximal phalanx of the thumb. So that's this bone there. There's proximal distal phalanges of the thumb. There's no middle phalange. There's no middle phalanx for the thumb. Base of proximal phalanx of thumb or pollex. Let's remember phalanx is singular for phalanges. Moving on. Extensor Palmaris Longus. It's a long tendon. The muscle kind of ends around there. There's a long tendon that extends all the way out. Base of distal phalanx of thumb also extends thumb. So change that to longus. Extends the thumb. That's the same. That's the same. Change this word to distal. And there you have it. Some questions for you. Take a look at those. Let's go through these. Number 1, which compartment of the forearm are the flexors in? Anterior compartment. Which compartment of the forearm is innervated by a radial nerve? Posterior compartment is. Which muscle of the posterior compartment is a flexor? That exception muscle, root beer drinking muscle, the Brachioradialis. Forearm flexors all originate from medial epicondyle. Forearm extensors all originate from lateral epicondyle. The insertion of extensor Palmaris Longus, I still got it up here. Distal phalanx of thumb. Number 7, I want to give an example of a gimme question. the action of Abductor Palmaris Longus. So don't even just try to remember by brute force. I tell you the name, you know what it does. This one abducts the thumb. Okay. All right. So yeah, this lecture has been posted in 3 parts. I didn't mean to be 3 parts, but my phone ran out of memory, so I had to chop it up into 3 parts. It was a lot of slides. So for the lab, I'm going to put together a bunch of muscle figures that you can study at home. So be looking for that on Canvas.